Yinotheria is a proposed subclass that contains a few fossil mammals of the Mesozoic and the extant monotremes. Today, there are only 5 surviving species, which live in Australia and New Guinea, but fossils have been found in England, China, Madagascar and Argentina. The surviving species consist of the platypus and 4 species of echidna. Evolutionary history. According to genetic studies, Yinotheria first diverged from other mammals around 220 to 210 million years ago, at some point in the Triassic or early Jurassic. The oldest known fossils are a bit younger, dating around 168 to 163 million years in the Middle Jurassic. These fossils of the genera Pseudotribuses of China, Yinotherium of both China and England, Atatodon of Siberia and Paratotodon of Kyrgyzstan and England. These belong to the family Yinotheriidae, and they're the only known Northern Hemisphere group of Yinotherians. Around the same time as Yinotheriidae, the infraclass Australosphaenidae first appeared. The family Hyenosphaenidae occupied in the Southern Hemisphere in Argentina and Madagascar with genera Hyenosphaerus, Ambondro, and Asphaltomylos. This suggests that this family could have been more widespread and diverse in Gondwana during that time, although due to the fragile state some species might have been destroyed due to geological events. In the early Cretaceous in the region that is now known as Australasia, the family Australosphaenidae and the first monotremes appeared, despite being found in the same region of the world and same time period. Recent work has found that the older Hyenosphaenidae is the sister taxon to Monotremata, with Australosphaenidae being the next sister taxa in Australosphaenidae. Australosphaenidae includes the genera Bishops and Australosphaenus. A monotreme fossil of a jaw fragment 110 million years old were found at Lightning Ridge, New South Wales. These fragments, from the species Steropodon galmani, are the oldest known fossils of monotremes. Fossils from the genera Collicodon, Taenolophos, and Obdurodon have also been discovered. In 1991, a fossil tooth of a 61-million-year-old platypus was found in southern Argentina. Molecular clock and fossil dating give a wide range of dates for the split between echidnas and platypuses, with one survey putting the split at 19–48 million years ago, but another putting it at 17–89 million years ago. All these dates are more recent than the oldest known platypus fossils, suggesting that both the short-beaked and long-beaked echidna species are derived from a platypus-like ancestor. Systematics. History of classification. Prototheria. Originally monotremes were classified as a subclass of mammals known as Prototheria. The names Prototheria, Metatheria and Yinotheria refer to the 3 mammalian groupings which have living representatives. Each of the 3 may be defined as a total clade containing a living crown group plus any fossil species which are more closely related to that crown group than to any other living animals. The threefold division of living mammals into monotremes, marsupials and placentals was already well established when Thomas Huxley proposed the names Metatheria and Yinotheria to incorporate the 2 latter groups in 1880. Initially treated as subclasses, Metatheria and Yinotheria are by convention now grouped as infraclasses of the subclass Theria, and in more recent proposals have been demoted further, as cladistic reappraisals of the relationships between living and fossil mammals have suggested that the Theria itself should be reduced in rank. Prototheria, on the other hand, was generally recognized as a subclass until quite recently, on the basis of an hypothesis which defined the group by 2 supposed synapomorphies, formation of the side wall of the brain case from a bone called the anterior lamina, contrasting with the the alisphenoid and a linear alignment of molar cusps, contrasting with a triangular arrangement in therians. These characters appeared to unite in monotremes with a range of Mesozoic fossil orders in a broader clade for which the name Prototheria was retained, and of which monotremes were thought to be only the last surviving branch. Australosphaenidae hypothesis and Yinotheria. The evidence which was held to support Prototheria is now universally discounted. In the first place, examination of embryos has revealed that the development of the brain case wall is essentially identical in therians and in Prototherians. The anterior lamina simply fuses with the alisphenoid in therians, and therefore the Prototherian condition of the brain case wall is primitive for all mammals, while the therian condition can be derived from it. Additionally, the linear alignment of molar cusps is also primitive for all mammals. Therefore, neither of these states can supply a uniquely shared derived character which would support a Prototherian grouping of orders in contradistinction to Theria. In a further reappraisal, the molars of embryonic and fossil monotremes appear to demonstrate an ancestral pattern of cusps which is similar to the triangular arrangement observed in therians. Some peculiarities of this dentition support an alternative grouping of monotremes with certain recently discovered fossil forms into a proposed new clade known as the Australosphaenidae, and also suggest that the triangular array of cusps may have evolved independently in Australosphaenidans and therians. Australosphaenidae is characterized by the shared presence of a cingulum on the outer front corner of the lower molars, a short and broad talonid, a relatively low trigonid, and a triangulated last lower premolar. The Australosphaenidae hypothesis remains controversial. For example, there seems to be a presence of lingual singular in various non-Australosphaenidan mammals, and some work has shown the possibility of Yinotheria being the sister group to Australosphaenidae, without monotremes. As a result, some taxonomists prefer to maintain the name Prototheria as a fitting contrast to the other group of living mammals, the Theria. In theory, the Prototheria is taxonomically redundant, since Monotremata is currently the only order which can still be confidently included, but its retention might be justified if new fossil evidence, or a re-examination of known fossils, enables extinct relatives of the monotremes to be identified and placed within a wider grouping. When systematic work was performed, it was also found that Australosphaenidae is the sister taxon to Yinotheriidae, an obscure group of Mesozoic mammals that found in what is now China. Kyle and Jaworowska, Sifeli and Amp. Luo 2002 had this to say regarding the Yinotheriidae, particularly Yinotherium. In our view, the most compelling evidence as to the affinities of Yinotherium lies in the structure of the last premolar, which shares striking similarities to that of Australosphaenidae. Lower molar structure of Yinotherium and Australosphaenidae is obviously quite different, and for this reason we do not place Yinotherium within this Gondwanan clade. Based on the limited evidence available, however, we suggest that Yinotherium is a viable sister taxon to Australosphaenidae. Yinotheria is named for this grouping taxonomy in comparison to Metatheria and Yinotheria, where there seems to be a better understanding on the relationships among taxa with substantial fossil evidence. Yinotheria has few fossils, mostly consists of the jawbones and teeth. In addition, the group seem to have not been as diverse in their evolutionary history, in comparison to members of both Metatheria and Yinotheria. Future analysis and better fossil remains could affect the membership of Yinotheria, as well as rearranging and revising the relationships of stem monotremes and crowned monotremes. Yinotherium Shilongi Wang et al. 1998 Infraclass Australosphenodoluo Cephalian Amp Kielanjorovska 2001 Sensu Kielanjorovska Cephalian Amp Luo 2004 Order Australosphenodoluo Cephalian Amp Kielanjorovska 2001 Family Australosphenodidae Rich al. 1997 Genus Bishops Rich al. 2001 Bishops Whitmore A. Rich al. 2001 Genus Australosphenis Rich al. 1997 Australosphenis Nictus Rich al. 1997 Order Henosfrida Avrianoff and Amptalopaton 2011 Family Henosfridarugia al. 2007 Genus Ambondro Mahabo Flynn al. 1999 Genus Asphaltomylos Rauhat al. 2002 Asphaltomylos patagonicus Rauhat al. 2002 Genus Henosfrus rugia al. 2007 Henosfrus molus rugia al. 2007 Order Monotremata Bonaparte 1837 Sensuluo Cephalian Amp Kielanjorovska 2001 Genus Cryarictes Pridmore al. 2005 Cryarictes Cadbury Pridmore al. 2005 Suborder Tachyglossa Gill 1872 Family Tachyglossidae Gill 1872 Genus Megalobguilia Griffiths, Wells and Amp Barry 1991 Megalobguilia robusta Megalobguilia Ramsey Genus Zaglossus Gill 1877 Zaglossus Hacketi Glauit 1914 Zaglossus bruania Zaglossus Attenborough E. Flannery and Amp Groves 1998 Zaglossus Bartoni Thomas 1907 Genus Tachyglossus Oliger 1811 Tachyglossus Achillolita Oliger 1811 Suborder Platypida Gill 1872 Family Collocidontidae Flannery al. 1995 Genus Collicodon Flannery al. 1995 Collicodon Ritchie A. Flannery al. 1995 Family Steropodontidae Archer al. 1985 Genus Taenolophos Rich al. 1999 Taenolophos Trusleri Rich al. 1999 Genus Steropodont Archer al. 1985 Steropodon Galmani Archer al. 1985 Family Ornithrinchidae Gray 1825 Genus Monotrematum Pascal al. 1992 Monotrematum Sudamericanum Pascal al. Obdurodon Dixoni Archer al. 1992 Genus Ornithrinchus Blumenbach 1800 Ornithrinchus anatomus Blumenbach 1800 Phylogeny below is a simplified tree on Avrianoff A.